Hello, welcome to the DSL podcast. I'm your host, Dave Cole, and we have Mike Tamir on today's episode as our guest. Welcome, Mike.
Thanks for having me.
Good, good. Mike, just a quick background on you. You are currently the chief ML scientist and head of machine learning and AI at Susquehanna. You want to tell me a little bit about what is Susquehanna?
Yeah, so Susquehanna is a financial institution. So we work with investments and looking at different signals in the market. It's pretty exciting place to do machine learning. I've been interested for years in what are the challenges, and is it possible to separate signal from noise in this very low signal noise ratio context?
Yeah.
Especially with with the whole spectrum of ML techniques, and so it's been exciting to be able to actually test a lot of those hypotheses the last several years.
Well, if you look over your background, your LinkedIn, you've also spent time at Uber, but you've been in a DSL for many, many years. And on today's podcast, what we're going to dive into a few things. First of all, we're going to talk, given, I think one of the other things that also is interesting about Mike is a very famous DSL. There's quite a number. He's a prolific Twitter user. Please follow him on Twitter, and he sends out tweets, multiple tweets a day, it seems. We'll talk a bit about that and sort of building your social profile as a DSL. The other thing is he's on a list of top 100 most influential people in AI from AI experts. I looked that over, and it's got Elon Musk in there, and as well as Mike. So your reputation precedes you. You've clearly had an interesting career. So we're going to dive into I'd love to get your perspective on the future of data science, as well as what you've seen in the past, like it's sort of where you see the trajectory of AI, machine learning, et cetera. Also, we're going to talk a little bit about machine learning platforms. Uber, with your experience at Uber, Uber has open sourced a data science platform called Michelangelo. Taking a step back, where do you see a place for a data science platform? How important it is? Do you feel it is for a team of data scientists in terms of improving their performance, et cetera, et cetera? And then we'll even touch on a bit on fake news. So we'll talk a little bit about that towards the end, because I know some of your expertise is in NLP, and there's some interesting things that you've done there. So, cool. Without further ado, let's talk a bit about what you've seen over the last 10 years, and then what do you see going forward in the world of data science?
Sure. Last 10 years, so we're coming up on a 10-year anniversary of that Harvard Business Review article, where I think was the first time most people heard the name data science, or the title data scientist, right? The sexiest job of the 21st century. And certainly the terminology has evolved quite a bit. Maybe people that were once traditionally referred to as analysts are now, at least some of them, some of them are doing business intelligence, but a lot of them have rebranded themselves as data scientists.
Right.
Something that is certainly been a change in the industry is the level and degree to which people are open to using, or companies are open to using, machine learning. And so data science, in many cases, encompasses the machine learning engineers and the machine learning scientists role. Yep. It also in certain companies has data science sort of merged with that role and that function of being the people that do machine learning, as well as doing maybe some data engineering, data exploration, to people that do all of the exploration and the analysis, whereas then you have specific specialists that focus on doing the research and the architecture and the advanced machine learning modeling, which is something that sort of came in and came out again. I don't know if the term data science or data scientists specifically, what the future for that is.
Yeah.
But certainly there are these core functions of doing the engineering on the data side, doing the engineering on the platform side, which I know we were going to talk about, and doing the actual experimentation, which is more of a science
Right.
component, as well as analyzing or exploring the results of those experiments. And that's really where if there's a common thread in what's core to data science, I would say that's it, even more than doing machine learning or using specific techniques.
Right. So I guess in summary, if you look just from a role perspective, looking back 10 years, there's been, first of all, the phrase, the role itself, data scientist, was coined about 10 years ago. But then there's these other sort of roles that have come to be that, maybe always existed, but, it didn't, there wasn't a specific name for the role. It was sort of under the, maybe IT handled it, or, your statistician was doing some of this and didn't see it as a full-time job. But now you have ML engineers, folks on the ML ops side, folks who are responsible for putting models into production. And that actually, is it fair to say that it is sort of improve things, streamline things, allowed the data scientist to focus more on the experimentation, more on the science?
So certainly as the career path or paths, we've matured in our understanding of how to build a data science team. Those teams have benefited quite a bit from being able to be more precise on the different kinds of roles. I don't just hire data scientists anymore. I hire ML engineers and data engineers and scientists to do the experimentation, and people for all of those specific roles. And there are certainly different skill sets that are required for those. And what certainly happens if you don't do that is you end up hiring somebody. Either you wait until you hire someone that is excellent in everything, and that they used to talk about data science unicorns.
I was going to say, yes, a unicorn. Yeah, good luck on that approach.
People. Yeah, and then you never hire people, or you hire people and you're disappointed because they can do A and B but not C. Or you figure out specific skills, you test for those skills. Maybe it's good that they have overlap in other skill sets, but if you hire for the specific, just like building any other team, if you have a job to do, make sure that you have coverage of all the skills that are needed, and the ability for everybody to grow and maybe into the other directions, rather than waiting for the perfect person that can do everything, which then they talk about what if they get hit by a bus, then you're in trouble, right?
Yeah.
So even if you find
the key person risk problem.
Person,
So let's just for our audience, and even maybe for me, if you could just give a one sentence description for each of these roles, let's start with the easy one. How would you define data scientist, and let's go down to ML engineer, data engineer, and so on.
So data scientist, certainly, in the meaning is use, maybe the broadest of the terms.
Mm-hmm.
I mentioned earlier the core, the center of that Venn diagram that is really in every data science role is the data exploration and the experimentation.
Yep.
So whether it's a heavy machine learning role or not, if you have models that are tasked with estimating or predicting or figuring out what's going to happen given the data, an ineliminable job that any data organization needs is the ability to see how well did this model, or how well are we doing. So looking at the outputs and seeing how close they are to the target that you want to hit, and looking for stratification of the different data points, looking at where your mistakes are, and coming up with hypotheses for why maybe, we're using this word here and it's confused about that word because it said president and it thought it meant Trump and not Biden, because there was just an alteration, things like that.
Temporal
that
aspect.
You can kind of explain what's going on and come up with tactics to fix it. So doing that, you may call it residual analysis, figuring out how seriously can we take these top line results if we dig down. On the other end, which we're going sort of in reverse order. Before you even build a model, you have to actually understand your data. You have to understand which features there are, what kind of feature engineering you need to do for those features. You need to come up with hypotheses for ones that, working with subject matter experts on what to throw out. So preparing the data and getting it ready. And then if it's a machine learning focused a data science role, then you're going to also build the model. You're going to get that ready and sort of stitch it all together. Now let's move out from there. Or we can move out, actually, you can think about it in two directions, right? So if you have like an ML scientist or an ML scientist who's doing the experimentation, hey, I think that I'm seeing this phenomenon. Maybe I'm doing the data science function of looking at, we're making this mistake, or maybe the numbers are low in this or that region, or, so I'm either working with a data scientist or I am playing that scientist role, then I'm going to come up with hypotheses. I think that by changing the architecture in this way, or by changing the feature preparation in this way, or by, doing, whatever other mechanisms you have, like how the model trains and how, other techniques that you just, you're reading in your research. The scientist is going to, and the best way that they could do this, the ML scientist, is to set up an experiment. And this is how, with my Berkeley students, they have to create a term paper every year, or every semester that they do it. And so I always say, well, this is like, just like with my son who's in 5th grade, who does his science fair reports. What's your hypothesis? What's your treatment? What's your control? How are you going to? And so this is the way that if you're an ML scientist, a data scientist role, you're really going to approach that. And now what your phenomenon of experiment is that combination of ML tactics or modeling tactics more generally, and data. And you make a hypothesis that, hey, this is the thing that's happening. I want to fix it. I think tactic A or B or C is going to improve that. And then you experiment, and now you have to analyze your results. And so there's that virtuous loop between the data science role of residual analysis and feature engineering and the ML side, which, data scientists hopefully get a chance to do that too. I find that to be some of the most fun. So now let's work our way outward, right? So that was kind of like the middle part. Let's work our way outward. So getting the data, so there's this also this role of data engineering. I really see that as a role that may be interesting in the machine learning and what happens to the data and how it's analyzed, but is really more focused on making sure that at scale you're getting the data you need, you're processing in the right way, if for production purposes especially, but also for high scale experimentation purposes, that you're having that be prepared and in a distributed computing environment such that your data is ready at the speed that it needs and goes through the right transformations that will minimize the extra. You want the scientists to focus on the experimentation. You want the engineers to focus on the optimization and the speed with which the data gets as close to ready as possible for experimentation. Right. Now, feature engineering is part of experimentation, so that's not to say that data scientists don't do feature engineering and don't work with data. They do quite a bit. That's a core part. But getting it to that process and eventually handing off as much of that boilerplate or that those known settled transformations as possible are going to be important, in particular for production. Maybe going more horizontally, so where are you actually building this modeling? Where are you running these experimentations? And again, the name of the game here is you want to make the experiment, the people responsible for experimentation, you want to make sure that they're focused on running the experiments, analyzing the results of the experiments, and doing that iterative process, and not worrying about doing all the boilerplate of, am I running everything on my GPUs right? Am I distributing across my GPUs? Do I have the right metrics? Is this the same metrics that this other department are using? Are these the same metrics that the other department are using? Is this the right data? Is there any corruption due to data leakage somehow? Am I using a pre-trained model that already saw the test data somehow? All of these management components ideally is going to be controlled by a platform, a centralized platform that any modeling group, any group responsible for working with data and drawing predictions from that data and experimenting on that data is going to be able to use. And that's really where I see ML engineering coming into place. There's basic engineering. Some of it overlaps with what data engineering is, which is just making sure you're keeping track of your data sets, your
Right.
data leakage type stuff. There's making sure that the implementation and the environment and the distribution across your the way you utilize your machines, in particular GPUs, and where you store your data, and is it on are you storing data in this in a high access place, in a low access place, all of those things, and then of course the techniques themselves. What kind of modeling techniques do the scientists want? What kind of, do they want to use, these models that are available in PyTorch, these models that are available in scikit-learn, and making that streamlined. What a platform should not be is a competitor to PyTorch or TensorFlow. That's
Right.
not what I mean by creating a platform. What it should do is, because no matter how many people you hire, you're going to not be outrun by the world's worth of contributors.
The open source world.
So what you want to do is be compatible with them and be able to leverage all of the things that the world is creating open source, rather than competing with them and trying to just outdo and rebuild wheels that have just been built, so to speak.
So we've hit up on a bunch of topics here. Let me try to summarize a little bit. So, like, if you were looking at the sort of the core responsibilities of a data engineer, a core responsibility of a data engineer is sort of getting the data prepped, so that the downstream data scientists can really do as many sort of high quality experiments as possible. Right. So the projects that they're working on, they can do more throughput from an experiment and a project perspective. And then whereas the ML engineers are really helping to build the underlying sort of data science platform, which we'll talk about in a little bit, which stores the actual experiments and the results of the experiments themselves, as well as, I assume, has some of the data that's being used for those experiments, so that those experiments can be recreated, and that you have sort of collaboration amongst the data scientists. And there's also a challenge of sort of reinventing the wheel. You want to make sure that data scientists aren't running, if you have Fred over here and Mary over there, both are data scientists, then they're not working on the same experiment, just from two different angles. And you want to make sure that they're collaborating, and sort of prior art is being discovered in a great way.
Yeah, so collaboration, working on the same data, working on the same problem is something that happens. I've never met scientists who see someone say, here's the data, here's the problem I'm trying to solve, these are our model results, that didn't say, oh, I could do better.
Right, yeah. That's the fun part. That's the fun part and sort of frustrating part of being in the data science world. It's not like software engineering, right, where you just you can develop an app that is to spec into requirements and it's done. There's always new algorithms, there's new approaches, there's different features you can use. And if you're a confident data scientist, you'll always see a problem and say, I can do better than that. Yeah.
Yeah. And so how do you actually get to the bottom of that? The cliche failure is they go off, they take the data, they build a model, and maybe they can do a little bit better. They say, hey, I got my MSE was this, or my cross entropy got down to this, right, or whatever it is, right? My F1 got to this, and that's better, right? And and that's where things start to break down, because you say, well, I don't know if it's better. They built that 2 years ago in a different department. I don't know. I don't have the metrics recorded, or I don't know what metrics they used, or I don't know what test data they used, or I don't know if you got to use more data, so maybe your model's not as good, but it just got more data. There are all these different ways in which the apples are not compared to other apples, and so a platform helps to standardize that. It helps to make sure that you're using the same library for metrics. So even if you don't know exactly the data, you at least know that you're using the same ruler, right? Ideally, it'll also you'll have a good data infrastructure and tagging, so you actually know, and you're versioning the data sets, so you know which data was used in order to get these results, what the volume is, whether or not there's leakage, and so you have that locked in as well. And then it's a matter of the particular model type, right? And if the particular model type, maybe you did it offline and then you brought it in and you migrated to your platform. There's an adoption thing, especially when you're first starting out with like a Michelangelo or an internal platform, of getting people to use your implementation in the platform versus what they can pull down from a public library. Ideally, you're pulling down what's in that public library and just making it accessible within the framework of the platform.
Right.
And then, once people see, hey, this is a real benefit, then they'll migrate over. From a high leverage point perspective, it's there are ways of encouraging this, which is the easiest one is to say, hey, what goes into production has to be used with the standardized library that we have for metrics, and then people will start to experiment. Now, ideally, you don't just if that's the stick, then the carrot is you make it a lot easier to do iterations more quickly. You make it easier to do what you already wanted to do, so you get over that hump of adoption that is people are used to doing what they're doing on the command line or in notebooks or in studios. So they have to not just see that it's as good, but see that it's much more effective than whatever they're using before.
So as host, I have to say, like, we started with the question, right, which is like, how has data science changed over the last 10 years? And we are actually hitting on this, audience. So we started with the fact that we had the data science role being created, but then there's these other roles that sort of were created. I mean, data engineering has been around for a long time. In fact, one could argue that like running experiments and building models has been around for decades as well. There's a new name for it, but I think certainly the ML engineer and building out a data science platform is absolutely new. I mean, that to me didn't exist 10 years ago, but they do today. And Michelangelo is one example of that. And then what we're talking about now is like, what are some of those key features that that you want to see in a data science platform? So that ability to be able to not just only look at the code that was developed and understand what what algorithm was used for a particular model and being able to see what features were being used, but also the data set that was used to originally train that model is also important too. And then also, what were the model outputs back in the day, right? Maybe the model maybe the the various model metrics were just as good as better as some model that you created right now. And all you really need to do is just use this. You just retrain the model on a newer data set or something like that, and make some small tweaks with the model itself. So all of that is data science platform can help. What other things did you see in your days at Uber, or do you want to see from a data science platform?
And so just to also to touch back on the question of what's evolved, I mentioned machine learning, and the willingness to use machine learning has certainly evolved from a, hey, why don't you try this, to so you read an article or you saw that this is possible, and now you just want it to happen, right? Even more so with deep learning, it's gone from go back to academia to why aren't we using deep learning? We have to have AI and deep learning in our in whatever we're doing, because that's the thing that works the best. And finding a middle ground there where you're using traditional methods, and then maybe you're seeing if it's worth it to, and you can get greater signal from doing more advanced techniques, is really where we're at now, and where the role or the set of roles has evolved.
And I sort of glossed over the fact that you're a professor at Cal as well in your spare time. I don't know how you lead a normal life with everything you got going on. And I believe you have expertise in not just NLP but also in deep learning as well. And I would be remiss if we didn't mention the cloud, right, as playing a large part in sort of helping data science really evolve over the last 10 years. And certainly that's played a huge part in deep learning, right? The access to GPUs and things like that were extremely expensive, very difficult to get your hands on, maybe 10 years ago, and whereas today, thanks to the cloud and other frameworks, are much easier.
Yeah. Certainly, we used to beg GCP for vouchers to give to our students so they could actually do their deep learning models, and now you have to wake up at like midnight and restart your GPU if Colab goes down. But I think for less than the price of a Netflix subscription, you can get a Colab subscription Pro, and you get lots of GPUs. You can run them for days, and that's really a night and day from trying to figure out how to make sure you have the right firmware and CUDA and all of that.
Oh yeah, that's a
That's
lot of
set
fun.
up on your Linux box, which
Yeah,
was the way it
absolutely.
was just not so long ago.
So let's touch a bit more on getting back to the data science platform. So what do you see? And maybe you can even touch on where you see the future of data science going. Like maybe that's bigger and better. What data science platforms? Maybe it's other things that you want to talk about.
Um, so So yeah, if you look at the life cycle, it kind of feels like around 2012, 2013, we hit this turning point in image, image-based tasks, and we've been doing marginal improvements and figuring out all sorts of corner cases and learning complexities and details with like adversarial and generative challenges. With text, that seems to have happened maybe at a 5-6 year delay from there. Now attention mechanism sort of is to language as convolutions are to images, and that's not to say that either one is the best and final way of working with these, but you're sort of getting into that role where you just kind of pour on more and deeper and longer training on using these sorts of fundamental tactics, and you have a language model that is better than any other language model, right? It's just a matter of making it bigger and bigger and bigger. What we still haven't done is, we haven't really solved the challenge of merging a lot of these together. So there's things like image captioning that are impressive but also sobering, right? So wow, I was able to say there's the monkey, but you can find all these corner cases. In language tasks in particular. So the glue benchmark, and it was replaced by super glue, which has a slightly different flavor of benchmarks. But like Bert and Roberta and all those all like in T5, and I think there's an Ernie is now the leader. I guess that's gonna date. It's April 8th for the record, 2021. Is the top right now.
Right.
All of these are really, a lot of the glue benchmark tasks were all about natural language inference. And in parallel with really just destroying natural language inference benchmarks, the MNLI came out, Glue came out like in 2018, and it had beat human performance within a year, and so they had to come up with super glue. Right? We're finding that there's a lot of information leakage there. So there's a lot of papers. I think a really good one, if you want to get into this, is looking at adversarial NLI, looking at the adversarial NLI papers or literature, and also looking at right for the wrong reasons. That's a good entry point into seeing what goes wrong with these. And so these models will be really good at detecting signals that are highly correlated, like, hey, they mentioned the consequent in the antecedent, right? So the model's really good at saying if the if part of the sentence said X and the then said something that sounds similar to that, I'm going to say that the if entails the then, and it's a good entailment. Whereas maybe if they don't have that, then they don't, and they're able to game the system to figure out that actually when you have that pattern, but it's clearly not, the if doesn't entail the then, the models do much, much worse. And so there's another layer of figuring out how much are we cheating, are our models cheating, and looking at things that maybe they shouldn't be making decisions to, even if it's from a statistics perspective in the particular data set that we are training them on and testing them on, it's a very useful tool to detect that signal. And so this is a data quality side thing, but it's also coming up with better tactics for making sure that our models are not right for the wrong reasons. I think sometimes, or it's possible, there's literature and adversarial imagery and adversarial features that you can inject into imagery that may take a similar, it's tough to say, but it may have a similar role where you have these sort of these adversarial features that models can use in order to be more accurate on their test set, but you get the feeling that if you just pull those adversarial features out or you apply them to some other false positive context, then you're going to get the wrong answer. And so we've done a lot of great work over the last 5, 6 years in understanding optimization, thinking about the way models learn, how cyclic learning rates and different kind of optimization techniques and ensembling and weight averaging and thinking about how local minima tend to cluster and how that generalizes. What we haven't done such a good job is thinking about ways to solve these right for the wrong reasons style problems, and that's another thing that I think would be really nice to move into. I haven't even talked about reinforcement learning yet. There's a lot of really cool stuff that's happening there in terms of having the agents create these representation models for world models is the term of art for what's going on, so they can do high speed planning on tactics, and more than the other two sort of like really fun generic playground areas. They've been really good at kind of taking from what we've learned in deep learning with image recognition and using that for generative modeling, and using that in order to make the reinforcement learning agents better.
So, in summary, help me out here, Mike. That was a lot for me personally to take on here, but NLP is improved quite a bit, although it's been a laggard when it comes to sort of image processing, and you see. There's still a ways to go when it comes to NLP and sort of improving the inferences that come from the various models built in NLP. And then switching gears and looking more at reinforcement learning, you see, there's some pretty exciting things going on there. If you were to dumb it down for the likes of me, I won't speak for anyone else who's listening, but when you say NLP and you say right for the wrong reasons, and we talk about reinforcement learning, just like help us understand a little bit more about what you're referring to.
And so I'm not going to remember some of the examples presumably as well as I should. So you can have like phrase matching is like one of the failures, right? So or let's just take a simpler case, which is maybe less compelling, but the judge gave an answer to the defendant. Okay. So if the judge gave an answer to the defendant, then it's the then sentence, or does that entail the defendant gave an answer to the judge, right? Okay. Or the judge said X to the defendant. Or the judge, the defendant, the judge said X near the defendant, or something like else that like has like strings of words that are in both the antecedent and the consequent.
Yeah, so you're trying to understand who was the judge talking to, and then who was when the defendant replied, was the defendant replying to to the judge or someone else, that kind of thing. Yeah.
And so what happens is as a symptom of the data set itself, the kinds of if sentence or A then B sentences, right? Or A sentences and a B is a sentence, so to speak, right? Mm-hmm. The A sentences and B sentence combinations tend to have entailment more when just those kind of brute force patterns emerge, like there is a copy of the text in A and there's a copy of that text in B. Mm-hmm. And there are more subtle versions that they go into also. And it turns out that when you remove that overabundance of I don't know, maybe that is accurate natural representation of the way people speak, but from a balanced modeling, right? Maybe the model needs to learn how to take care of those cases, but also take care of the cases where A and B don't have that matching pattern of sequences of text. And so, by figuring out how to get a model to learn from those harder cases, it's going to be better at, it's going to be more effective at generalizing into strata of text that don't have this kind of pattern, right? So it's this weird thing because, well, it works, and and you might say, yeah, but it, worked maybe you're just overfitting to the training set, right?
Right.
And then the rejoinder to that is, well, yeah, but we tested it with a holdout set, and we validated it with a holdout set, so it works on the real data too. And then you're getting kind of into the area of, well, yes, it's effective on the natural samples of text that you might get, of if-then sentences you might get, or A and B, and A entails B, or A doesn't entail B sentences or combinations that you might get. But it's very fragile in the face of making these perturbations, right? Changing the A and B, so that it's getting over dependent on this sort of like cheating way of detecting that A entails B.
Right. I think the bottom line is if a human can see the texts and can sort of imply on if A is leading to B and interpret it, then gosh darn it, our models eventually should be able to get pretty close to that. Maybe not perfect, but much better certainly than where it is today. So I think bottom line is, from getting back to the question at hand, where are we going from a future standpoint? There's still a lot of room for improvement on the NLP side as well. That's certainly fascinating. I think there's been an interesting journey just from a data science platform perspective that we've seen over the last 10 years, from the various roles that have been carved out because of that. We also touched a bit on just the improvements from so the data science itself, the algorithms that are being used, the advent of deep learning. All of these are sort of improvements that we should see more of going into the future. I also think speaking personally, that I think seeing there is a change management aspect in terms of data science, right? So the work and the output that we're doing, and having folks sort of embrace it as being more than sort of voodoo, and that explainability aspect, I think there's still some room for improvement there too. And actually having models being put into the center of enterprises and actually being used to make business decisions. I think we still have a bit of I don't know if you agree, but I tend to think that we still have a little bit of ways to go there. I think some companies have embraced it, right? Maybe in Silicon Valley more so than the rest of the world. I don't know. I don't know if you see that as a challenge as well.
So
So actually, having the business side sort of embrace, the outputs of models and putting the core of business. I imagine Susquehanna, being sort of a firm that is dealing in data and having models at the forefront of what they do. That's probably not a challenge, right? And then at Uber, probably not either. Having been a startup that is all about data, all about driving efficiencies and driving affordable trips for folks getting from A to B. But there are other companies who are not as data driven, but who are building out data science teams and who might be sort of struggling to see, to understand which use cases that they have had, sort of traditionally, and understanding where data science can be applied in those use cases. I think it takes sort of a strong DSL to be able to who's not just very strong from a data science perspective, but also can actually change hearts and minds and say, actually, we can solve this problem through the use of data science, right? So I think that can be a challenge, right?
Certainly. So it may be easier. You don't have to necessarily make the case that using modeling is going to be valuable, or could potentially be valuable. But when it comes to putting a specific model into production, mistakes can be costly. Mistakes can be costly if you're at a big company, if you're a small company, and so the more complex, the more ostensibly not transparent. There's been a lot of work in transparency, even for deep neural networks, and understanding how they work, why they work. But that really comes back to one of the things that we started with, which is the residual analysis. Understand, if you get a top line number, that's great, but understanding how that top line number is, where is it making mistakes? Why is it making mistakes? Is it making where is it getting things right? Is it getting things right because of this signal leakage, like the right for the right reasons examples? That's not even just because maybe I had data that shouldn't be in the training set. That's because there is information in your training data just by the way it was sampled or a large enough proportion of your training data, the model learns how to cheat. It learns how to cheat on the test data because of the way it was sampled and the same similarly
be
to
biased
the
in your data.
training data. Yeah. I remember it's not apocryphal because I remember hearing an interview, but one of the early Kaggle competitions, the woman who won saw that the serial numbers were actually not random, and so she put that in a feature, and it was really just supposed to be an index, but she ended up winning the competition. That sort of thing is maybe the most extreme example, but these are much more kind of less. That was just a face slap mistake, and more.
Yeah.
This is a complicated issue in terms of data sampling and data preparation and stratification of what you're training your model on.
Yeah, and I mean the output of that residual analysis, if it can help with the explainability of why your model is off by a certain percent, and why it's not as accurate as 100% accurate. Like if you can explain that, and it sort of can to your business counterpart. It can help build trust, right? And it can build faith in that, there's actual thought being put into how these models are being sort of architected, designed, and improved over time, right? And the more that happens, the more I think people will sort of embrace data science and putting it in critical parts of the decision making process, right? So, and we'll just see more of it. So I think that's. I think there's still some room to grow there. I think there are companies who've embraced data science and put it in the core of who they are, right? You can think Netflix is always an example that comes up all the time, and then there are others that are just going down that just really started that journey of the last 5+ years, and there's just a lot of like sort of nascent use cases where I think more and more adoption will be seen, hopefully. Last but not least, I do want to touch a bit on sort of the brand that you've built, right? So you are very prolific on Twitter. I did mention that at the outset. I did want to talk about that. Like, how do you do it? Like, are you reading all these articles? Because I don't know how you do it.
Yeah. So I don't do it 3 times a day like clockwork. If you notice, I have a schedule. What I do is every few days I'll sit down. I'll read all of the different links that I've saved throughout the last half week. I'll go through it. Anything that I think is interesting, or I don't necessarily share something because I think it's the right tactic, but at least it's an interesting tactic.
Yeah.
So I'll go through those and then I'll queue them up, and I have one of those social media things that just like that tweets them out one at a time.
Sends it out on a sort of scheduled basis. Yeah. That's fancy pants.
But that's how maybe doing it all at once, it's a little bit less onerous than every couple.
That's your trick.
Every few days,
that's
a lot
your
easier
trick.
than doing it 24/7.
But it's at Mike Tamir. It's very easy to get to. Follow Mike. He's on the cutting edge of data science, and he's always sharing lots of great articles, and I think it's clearly done a great job for you in terms of building your brand. And I think it's I think the important lesson though really is more than just like making a name for yourself on social media, but clearly you're passionate about the world of data science, and you're doing this to improve you as a DSL, right? You're reading these articles, I imagine, to really up your game. And I think that it's sort of a lesson to all of us that we always need to be learning, we always need to be reading, and there's always improvements to this like new algorithms, new approaches that we should be aware of, right, and make us better at our jobs.
Yeah,
absolutely.
When I left grad school, I had this terribly wrong impression. I was like, okay, well, I finished. There's the learning part, that's done, and now I'm going to go to the working part. And
if only, yeah.
And it was sort of like maybe a less of a dusting off my hands, and more of a I almost felt like I had to mourn the fact that like, I'm not going to be learning all the time
more.
anymore.
Yeah.
And pleasantly pleasantly surprised. It's not like that at all. It hasn't even been hard to make it part of the,
Yeah.
like make it part of my day to day and make it just like a mainline, learning new things. None of the tools, I guess I still use Python, but very few of the tools, almost none of the tactics, aside from fundamentals of this is good experimental practice, this is good machine learning practice, that might have stayed, but this particular techniques change so much.
Yep.
And it's fun to keep up with it and to use it and to see these ideas actually get put into practice, which is really where a lot of the juice is for me in my work.
Yeah, and coming full circle, I mean, that's why it's called data science, right? Because there is a science aspect to it. Like if find a scientist out there who's not experimenting and trying new things, and they're not a scientist anymore, right? They're not actually doing their job. I mean, their job is to experiment. Their job is to learn from their mistakes, to find to uncover additional insights through sort of research and that's what makes like kind of our space fun, is that it is purpose built to learn. Like learning is like core to being a great data scientist, and it should be core to being a great DSL as well. So if you want to learn more about Mike, follow him on Twitter at Mike Tamir. Also, you can find him on LinkedIn as well and reach out to him. But thank you so much for being on the podcast. I really appreciate it, Mike.
Absolutely. Great talking with you.